Geometry is a basic part of quite a range of applications, perhaps the simplest application being creation of figures and images. For example, this input shows an image created using a graphics expression and two graphics primitives. Graphics primitives are expressions like disk and rectangle that represent geometric elements. It's also possible to do calculations with geometric expressions, which can use the same geometric elements, but calculations typically involve region expressions rather than graphics expressions. For example, this input uses the same disk and rectangle expressions as in the previous input, but here those expressions are used in the region and region union functions rather than in graphics. Region union combines geometric elements into a single region, and the region function displays as a plot of the region. The region can then be used in calculations. For example, this calculates the area of that region. Graphics expressions and region expressions use many of the same geometric elements and have similar structure. The main difference is in how they can be used. For example, in addition to geometric elements, graphics expressions can look like this, with colors and styles and various non-geometric elements like text and labels. Region expressions use similar geometric elements but are specifically optimized for setting up mathematically meaningful regions. Region expressions can display with some general graphical elements like the tick marks and frame labels in this example, but only the geometric elements are considered when the region is used in calculations. For example, the area function ignores the frame labels in calculating the area of this region. A region can also serve as a constraint in mathematical calculations. For example, this shows an integral over a region. The integral with 1 as the integrand gives the same result as the area of the region. The constraint was entered in that example using the element symbol, which is a special notation for the element function. Geometric constraints also work in other functions. For example, this uses maximize to find the maximum of a function over that region. And this solves an equation subject to the constraint that the solution be in a region that consists of the unit circle. These operations also work in other dimensions. For example, this input constructs a region corresponding to a cone in 3 dimensions, and this uses that region to specify the range of the variables in an integral. Rather than using geometric expressions like cones and rectangles and so on, regions can also be specified using data or equations. For example, if this list of pairs represents points along the boundary of a 2-dimensional region, the corresponding region can be constructed by simply using that list of pairs in the polygon function. Regions can also be specified using symbolic equations. For example, this shows a region specified using equations that describe the boundary of the region. Regardless of how the region is specified, all of these regions can be used in calculations. For example, this uses that region as a constraint in the n-maximize function. In many applications, and especially in certain numerical calculations, it's convenient to work with regions that are approximated as a combination of simple geometric elements, usually triangles or rectangles. The Wolfram language includes a number of tools for constructing those sorts of regions. For example, this input uses the discretized region function to approximate the region from the previous example as a combination of triangles. Approximating a region with triangles or other geometric elements is sometimes called triangulation or mesh generation. Input form shows that the result in this example is a mesh region expression. This mesh region expression is several pages long, but the structure is not complicated. The first argument is a long list of pairs giving coordinates of the vertices of the triangles, and the second argument is a polygon expression that specifies a collection of triangles with those vertices. The structure can be understood more easily by considering a smaller example. This input shows a region expressed using mesh region as a combination of 3 triangles. That input also includes the mesh cell label option to add labels for the vertices. The first argument in mesh region is a list of pairs giving the coordinates of the vertices, and the second argument is a polygon expression where the argument of polygon, rather than using those coordinates directly, uses the position indices of the coordinates in that list of pairs. For example, the list 1, 2, 3 in the polygon expression specifies a polygon with vertices given by the coordinates at positions 1, 2, and 3 in the list of coordinates. The list 1, 3, 5 specifies a polygon with vertices given by the coordinates at positions 1, 3, and 5 in that list, and so on. A similar system for specifying coordinates and geometric elements can be used in graphics expressions, most generally with a special graphics primitive called a graphics complex. For example, starting with the previous input and replacing mesh region with graphics and graphics complex displays the same polygon as a graphics expression rather than as a region. Displaying the polygon as a graphics expression brings in the possibility of adding things like colors and text and so on. For example, here is a graphics expression that uses graphics complex and the same list of coordinates, but this time with triangle and text primitives and with styling to color the triangles. This image shows the triangles with vertices at points 1, 2, and 3, 1, 3, and 5, and 3, 5, and 4. This sort of structure, either in graphics complex or in mesh region, can be useful whenever different geometric elements share vertices or otherwise use the same coordinates. For example, here is that same image, this time with interactive controls for two of the vertices. Graphics complex in this example provides a natural structure that reflects the sharing of vertices between adjacent triangles in the image. Graphics complex and mesh region come up in many applications involving adjacent polygons or adjacent regions or other geometric elements that share coordinates. For example, this uses parametric plot to generate a plot, and input form shows that the plot is the displayed form of a graphics expression based on graphics complex. Geometry is a broad topic, and there are several places in the Wolfram documentation with relevant information. A good place to start is this guide page on geometric computation, which mostly describes computations involving regions. A list of geometric elements used in graphics expressions can be found in this guide page on graphics objects, and there is a similar list of geometric elements used in regions in this guide page on basic geometric regions.